Hi, this is Ahmad Mirabi. This short video is meant to be a representation of my online classes. Let's start. Okay, I want to teach a bit about oxidation number, which is a topic in redox reactions. What is oxidation number? Oxidation number is a number we assign to each element in a combination. Assuming that if that compound is made ionic, what is the charge of each element? That is called oxidation number. Okay, for example, let's think of uncombined elements. When we have uncombined elements, for example Cl2, the oxidation number of chlorine is 0, or for example in argon, which is a noble gas, the oxidation number is 0, or in Fe, which is iron, the oxidation number is 0 again. When we have compounds, for example we have H2O, now we need to assign oxidation number to each one. There are some rules for oxidation number. Let's review the rules first. Okay, the rules we have for oxidation number is that for example fluorine always will be -1. Why? Because fluorine is very electronegative, so whatever atom or element combines with fluorine, it loses electron and fluorine gets electron. Fluorine is in this 17th group, so it has 7 electrons in the outermost shell, so it usually wants to get 1 electron. So in compounds where we have fluorine oxidation number will be -1. Hydrogen will be usually +1. This is usually, but there are exceptions in hydrogen halides. For example in NaH, then here oxidation number of sodium will be +1 and hydrogen will be -1, because sodium and some metals are less electronegative than hydrogen and they will lose electron. And oxygen will be usually -2, because oxygen usually wants 2 electrons to be like a neutral, to be like a noble gas, which means it has 6 electrons in the outermost shell. If it takes 2 electrons, it will be octet. So, but there are some exceptions for oxygens when it combines with fluorine. Of course, because fluorine is more electronegative, fluorine gets the 2 electrons. If each fluorine gets -1, so oxygen will be +2. Or in the case of peroxides like this, oxygen will be -1 and hydrogen will be +1. So these are 2 exceptions for oxygen in the peroxide and compounds with fluorine. In other compounds, oxygen will be, because oxygen is the second most electronegative element, it has a greater electronegativity than all the other elements, so it will get electron, or it is stronger than others in terms of electronegativity. So for example in here oxygen will be -2 and hydrogen will be +1 as usual. Other rules we have for oxidation number is that, for example, first group elements like sodium, lithium and potassium usually will be +1, because they want to lose 1 electron, and second group elements like calcium, magnesium will be +2. Let's do some practice. This is enough for the rules, and if we do some practice you get the hang of it. For example, let's think of SO3, which is sulfur 3 oxide. Oxygen, as mentioned, is more electronegative and takes 2 electrons. So we have 3 electrons. We have 3 oxygens. So the whole oxidation number will be -6. So sulfur needs to be positive 6 to neutralize this compound. A compound, the total oxidation number of in a compound must be 0, because it is like charges. It is like charges, as if sulfur has lost 6 electrons and each oxygen has gained 2 electrons. It is like this because we were assuming that this is a ionic compound. Let's talk about some other cases. For example, in ammonia gas, nitrogen will be -3 and hydrogen will be +1, because hydrogen is less electronegative, it loses electron. And in some other cases, for example, in nitric acid, nitrogen will be +5. Why +5? Because hydrogen is +1, oxygen is -2, so nitrogen must be +5 to neutralize the charge of this compound. So as you see in here, the nitrogen oxidation number varies from +5 to -3, and this is in agreement with the place and nitrogen is in the periodic table. Nitrogen is in the fifth group of the periodic table, or 15th group, or fifth main group. So it has 5 electrons in the outermost shell. It can give 5 electrons, so +5 is the greatest oxidation number it can be, and -3 is the lowest oxidation number it can be, because it can, if it takes 3 electrons, it will be octet. So in the case of sulfur again, because it is in the 16th group, it has 6 electrons in the outermost shell, so the greatest oxidation number is +6 and the lowest oxidation number is -2. This is the greatest or lowest oxidation number an atom can have. Okay, of course, in some cases like metals of the first group, we talked about earlier that they can only get the +1 charge. Okay, now let's talk about oxidation and reduction. If oxidation number increases, we say that that element is oxidized. Oxidized. And if oxidation number decreases, we say that it is reduced. For example, let's think of this reaction: tin plus nitric acid gives tin oxide plus 4NO2 plus 2 molecules of water. In here, let's think of the oxidation number. This is this is not a compound, so oxidation number is 0, and tin in here, oxidation number will be +4 because each oxygen gets -2, so it must be +4. So in here, tin is oxidized. And then hydrogen is, of course, +1. Here again, +1. Oxygen is -2. Oxygen and hydrogen, most of the time, the oxidation number is fixed. What about nitrogen here? Nitrogen, the oxidation number is +5 here, but in here the oxidation number is +4, so the oxidation number is decreased. So this is, nitrogen is reduced. In each oxidation or oxidation reduction reaction, or which is usually named as redox reaction, one element needs to be oxidized and one element needs to be reduced. These elements can be the same, but at least one atom needs to be oxidized and one atom needs to be reduced. so that we call it a redox reaction. I can make another example that the same element gets both reduced and oxidized. Let's make this final example for this short video. Here we'll have chlorate as a product plus chloride ion plus water. Of course, this is unbalanced reaction. What is the oxidation number of chlorine here? 0. What is the oxidation number of chlorine here? It is positive 5, and here it is negative 1. So once chloride here is oxidized, and another time this is reduced to be negative 1. So the same element here is oxidized and reduced. Okay, it's enough for this video. I just reviewed the concept of oxidation number and reviewed some rules, and then I made some examples of redox reaction in which one element is reduced and one element is oxidized.